One of the technologies that is changing chip design these days is chiplets. It's an approach that's much more modular, but it's significantly different than putting everything onto one die. So Syed, could you tell us a little bit about, why people are taking a look at chiplets at this point?
Yes, thank you for having me, Bill. Chiplet is getting a lot of attention nowadays because, as we know, Moore's law, in its traditional sense, in terms of scaling, is almost reaching its limit. And I want to be careful. Every time people say Moore's law is slowing down or Moore's law is going to be tough, we see advancement on the latest nodes. So currently, as we go into 5 nanometer, 3 nanometer, is becoming technologically difficult. Also, we're looking at it, economic viability of going into all of these lower nodes with the prices of design and manufacturing at all of these nodes. So how do you get the scaling by looking at other things, by looking at additional things in addition to just shrinking the die? So chip makers are now turning back to a concept which has been discussed for a long time. Rather than manufacture a chip on a single piece of silicon, instead combining individual functional dies into a chiplet, which may be the next frontier in achieving the Moore's law and advanced manufacturing at scale.
Now, you talked about going to smaller and smaller nodes. One of the other advantages you have with chiplets is the different chiplets don't have to be made at the same technology level, and they may have different functions, for example, analog versus digital.
Yes, you're absolutely right. As we were discussing earlier also, you can have a AI specific processor combined with a generic or a standard memory module, and then take some other dies to form a chiplet, and it helps with the design, time to market, and the manufacturability of these chips also.
Now, there are some standards that are sort of emerging. For example, high bandwidth memory, HBM.
Yes.
How does that come into play with some of the other pieces? Are we going to see other standards that are going to be emerging, either from processor or interface type?
Yes,
port?
you're absolutely right. One of the things benefit of chiplets is this: you can have die from multiple companies come together, and this requires collaboration across different companies. So one of the things that's being considered is Universal Chiplet Interconnect Express, or UCIe, and there's a chiplet consortium across many large players that are serving the basis for a multi-vendor connect solution.
Now, there are different technologies out there available. We're not going to necessarily dive into all of them, but just having chiplets is not just the endpoint, but more of the starting point. What are some of the different approaches in terms of either using different carriers for the chiplets or directly connecting chiplets together? What are some of the options that are out there?
Yeah, I mean, there are the most common ones are fan out, 2.5D, 3D. Fan out utilizes the dies and distribution layers to combine different chiplets. It's not considered as not as fast or power efficient as other architecture system, but it has its benefit of being easily testable and therefore much faster time to market. 2.5D packaging uses an interposer for stack inter-chiplet communication. This leads to higher communication rates and can be paired with stack memory, as you talked about earlier, to make high-performance modules. Well, this could be the interposers that enable this 2.5D architecture, however, could be expensive sometimes as relative to other methods. Lastly, there's a lot of discussion about 3D nowadays. 3D is basically the same concept as 2.5D with chip stacking, but involves stacking logic on logic chiplets through silicon TSVs to yield the highest performance chip designs. So you have all of these different approaches, whether it's fan out, 2.5D, and 3D, and they have their own pros and cons, and companies pick those based on their needs.
Obviously, a lot of chips these days are made in foundries. Are the foundries driving some of this technology, or is it coming from other customers?
I think foundries are the main enabler for some of these technologies. Some of the large fabless companies working very closely with foundries. It's a very important collaboration that's enabling this thing. I mean, these things, as you know, requires a lot of collaboration across the silicon engineering, package engineering, chip designers to work to work together to have a rollout of these kind of technologies. So I would say some of the large IDMs, large foundries, obviously, and then fabless designers are working together to roll out these technology.
Now, are all the chiplets out there right now custom, or are there some standard ones? We did mention, the HBM, for example, but is this something where a designer is going to be able to come in and say, I want this chiplet, that chiplet, and so on, and this is how I want them wired together, and get them a chip made from that?
Yeah, I think we are, approaching, or maybe in some cases utilizing a similar approach. I think the designers are, as this becomes more common, designers are looking at, I should not say, template or a standard way of doing this thing, because standard has a special meaning in our industry. But they will look at the building blocks that they have utilized in the chiplets and to further expand that into other chiplets also.
So how do you see the adoption and usage of chiplets in terms of the next, 5 years? Is this something that we're going to see a significantly larger number of solutions based on chiplets?
Yeah, I think as we get into more solution approach, we will see more and more chiplets getting utilized. And as I talked about it earlier on, as we see the leading node silicon cost and manufacturing complexity increases, chiplets are going to get utilized even more, and especially the solutions, specific solutions required for AI will also increase the utilization for chiplets also.
Just to wrap up, could you summarize the benefits and some of the challenges that people are going to have when utilizing chiplets?
Yeah, one of the things that we talked about it a couple of times is already the benefits of scaling. Also, we are seeing this provides a very cost-effective packaging solution for combining chips or dies from different technology nodes. Also could help with the interconnect delays also helping develop the customizable solution, customizable complex solutions, while enabling the best of the breed or best of the chips from different vendors, and thus actually also helping lower the barrier of entry for some of the companies also. We are also seeing some of the advantage coming into some of the thermals. That's becoming an important issue for advanced architecture. So better thermal performance that drives better reliability. So I think these are the main benefits that we see in this area.
Okay. And how about the challenges that are still upcoming?
Yeah, I think the challenges, obviously, the manufacturing and manufacturing complexity, but also we talked about it earlier, especially if you're utilizing dies from different companies. And there has been some work on that one already, where we talked about having this UCIe, or Universal Chiplet Interconnect Express, which may serve as a basis for a multi-vendor future use. So I think those are the things that we need to overcome, and there's already been progress, as I said earlier.
Well, very good. Well, I appreciate your insights on chiplets design, and we'll definitely be talking more in the future. Thank you.